have a confession to make. All right, look, I'm not a super rich millionaire that makes really awesome things on the internet in a shop full of millions of dollars worth of equipment. I said it. And if you also fit into that category, you really want to check out this video of this really awesome header that I made, because I made this in one single day using only what you see here on this table. Welcome to the Fabrication series. You should do that. Thanks. So some time ago, I said that you could build just about anything with a grinder, a welder, and a computer. Now my goal has always been to find a way to prove that to you, because realistically, there's enough online services out there and ways to communicate with different people to get the job done that you need to get done. I mean, that's how we all get started, right? You do something, you sell it, you make some money, you reinvest. That's how we all get started, right? You continuously grow. But I've been on YouTube for like almost 10 years now, and I'm pretty sure I know what the comments would say when I tell people that you're gonna have to spend a lot of time going back and forth between these different manufacturers and online services. You're gonna spend hours finding that one manufacturer is too big for you. They don't want your work. Or you're gonna find that one manufacturer only offers half the services that you require, while the other manufacturer that offers the other half of the services you require has a minimum that you can't hit. Trust me when I say I'm pretty sure that you're going to dislike it as much as I do, because I absolutely detest having to go back and forth between these different companies only to find this out. It's a big waste of time, and it's for that reason that I kind of abandoned the idea. I've struggled to find a place to do it, all the way up until Xometry hit my inbox announcing that they now offer tube laser cutting and tube bending services. But in that email was also a request from Xometry to see if I could build something really cool that utilizes those services like tube bending, laser cutting, and maybe a couple of other things, so that they can display it at their IMTS booth in Chicago. The only problem is by the time I would have had everything, my tight schedule and everything else, it left me with one day to make this happen. But I also realized that's an excellent time to show you guys that you can make just about anything with a simple amount of tools, or a limited amount of tools, and a limited amount of time. Like, you could bang this thing out, move on to the next thing, and off you go. I am not making this video an infomercial about Xometry. They really are a useful tool or a useful resource to have when you don't have the machines, or when you don't have the time to go back and forth between a whole bunch of manufacturers. I mean, all you have to do is upload your file to Xometry.com for instant pricing, lead times, and design for manufacturing feedback, which, if you don't know what DFM is, it's basically like a second opinion. So if your design is like super complex and would cost a fortune, there's this little thing up there that says, hey, you might be able to simplify your design, which would effectively make it cheaper and more efficient to produce. That's really cool to have, even if you're not buying it. I don't know if I should say that, but that's what I use it for sometimes. And it's really convenient. And even my CAD software has the free Xometry extensions in it, because I am too friggin' lazy to save files to my computer and then re-upload them to the internet. I like to just click on the extension, pick out my process, pick out my material, pick out my finish, get the pricing, and go from there. And while I was building this header and sharing it to Instagram, I had a little bit of feedback where people were like, that's just way too expensive for stuff like that. Well, it costs a lot less than the machines that make it. So if you can't afford the machines, then you shouldn't be complaining about the pricing, because it's really not that bad. Honestly, I've been a customer of Xometry's for years. So I've never been let down. And I did ask for a little kicker for you guys, the viewers. And in the top comment for the month of October, there is a deal for you guys. If you utilize it, maybe they'll give me another one to give back to you guys. So you'll have to keep on checking back on this video and in that comment. So I got straight to work, hopped onto SolidWorks, drafted up this really friggin' awesome header that's going to utilize all the different services like laser cutting of sheet, that's going to be our flange, tube bending, which, you know, you gotta make these things go all over the place, right? I want to see multi-dimensional, like 3D bending, right? Not simple 2D planes, hang a left, go right, 180 there. I want it on multiple planes. I want to see these tubes crisscross. I want super tight tolerances with little margin of error for interference. That's really going to test out how accurate these machines can be. The merge collector is going to be 3D printed, and I'm going to make it a vortex style, which is an idea I had like 20 years ago to do. And then we're going to finish it off with like a bologna sliced exit tube with like the Xometry X in it. So with all of this said and done, uploaded all of it to Xometry, got the quote on it, pushed the button, and before you know it, it's right here in front of me. This is a pretty big heavy box. Now I tried kind of pushing Xometry on this one to like really test them. They got this really cool guide to follow along with. So like distance between bends and, you know, center line radii and everything else like that that you would typically want to follow. I tried testing that on this to see if I could maybe sneak past or whatever. So some of my bends are too close together, and they immediately, as soon as it's uploaded and whatnot, there was somebody contacting me saying, hey, we need to resolve this because your bends are too close together, and you know, not a single machine in the world can deal with that. So this right here is runner number 2, and it's supposed to have another piece that goes out this way. But since that would collide with the machine and it's too close together, then they couldn't do it. I said, all right, well, let's just split it, and then I'll weld the two together. So that's what they did. I tried to cheat, but they wouldn't let me. But really good on the communication though, which I was really happy with. So these are the smaller cut pieces that we have to cut off and weld to make all of this work. You'll see all that. Now, I was really surprised to see the extremely detailed inspection reports for each tube. I mean, these included everything you needed to know about the part, like alignment and deviation data, and they even circled on the report the extra leg length requirements that need to be cut off for each side. Like, even though I have the model for reference, which has basically the exact same information on it, these reports make it super nice, quick, easy reference. That's all laser cut. It's crazy. All I did was upload this part, and then it gets delivered to my door. That's really clean. 1/2 inch laser cut stainless steel, 304 stainless. This is really nice. So the one I'm most excited about is here. In 2006, or maybe it was 2007, when I was in college, I had this idea to twist a merge collector, which would create a vortex inside of it, then would in turn basically turn your exhaust, the upper side of your exhaust runners, into a vacuum cleaner. And then once it swirls here, it would blow it out the exhaust, and you'd create a lot more motion in it. The technology had never supported being able to do this, and it finally did. So this is 3D printed 316 stainless steel. It's amazing what we can do with technology these days. Okay, now, lots of spaghetti, lots of mess. I gotta figure out what each one of these is and start putting it together. I have only a few hours to make this happen. See, look at the dimensioning and the model of this. Like it's 3D, right? So we're bending on multiple planes. That is so friggin' cool. This looks like runner number 2. Now, I'm gonna jump in here before the comments kind of blow up about the wrinkle in the tube. It bugs me as well, yes, it absolutely does. Xometry rejected that part from the manufacturer, and they told me about it right away. They said it would take a couple more days to do it. Unfortunately, that put a huge misalignment in my schedule. I mean, I had people that were ready to go to IMTS and pop into the Xometry booth and see it. Like, they wanted to see it, they were waiting for it, right? And I didn't have any extra days available for me to make this part or remake that tube or anything else like that. I could not delay it. So the call was on me. I made the decision to say, just send me the wrinkled tube. As much as it bothers me, you know, yeah, sometimes it's just the way it is. So yeah, that was my call. This software, I'm not sponsored by these guys or anything. I'm just trying it out. It's called Onshape. I know a lot of you guys are going to ask about it because, you know, CAD is like a crazy thing for most people. I use SolidWorks. It's really expensive. It's like, for everything, is like $8,000 or something like that. This is like half the price for the professional suite. I'm exploring it. We'll see if it's good. I don't know just yet, but so far it's pretty cool. They do have a free plan too, so I know that's everybody's big thing. They don't want to spend or invest money in anything. Oh, it's got to be for free. So yeah, they do. This is one seriously crazy bend. Look at how this, like when this is, all of these were like normal to the flange itself, so it actually bends past its point and then comes back in and then off that. This is nuts. Okay, I'm getting distracted here. I got no time to do this. Runner 4. This is runner 1. I know that automatically. So this is runner 3. This overbent one right here, this is definitely runner number 1. Because that angle right there is more than 90 degrees, so this is definitely a runner 1. So let me hide that. And look at this angle here, but this is runner 2. Okay, so initially I said I only wanted to use 3 tools with this, but unfortunately when they give you decimal dimensions that are very accurate, I have to use a couple more tools. But you guys can say in the comments, what do you think? I mean, yes, these are tools. I don't count these, marker and tape, like everybody's got that in their junk drawer, right? But yes, this caliper for precise measuring and a tape measure for less than precise measuring, you know, that's 5 tools, right, that we're up to now. So unless you guys don't count these as tools, it's really up to you. So each one of these, they tell me which leg is long. So it says 3.68. I'm gonna get 3 point somewhere around 6.8, probably here-ish, somewhere in there. And I'm gonna use my crappy caliper. This is a cheap caliper. And that's gonna give me more precise dimensions without having to worry about messing up a good tool. So 3.68 and, well, what's 1/1000th of an inch? I'll scribe that. Now I'll use the tape as an edge. So if we follow this all the way around, and if the edges match up, then we've got a nice pretty straight guide that we can use to hand cut. Now yes, I badly want to plug in that saw and use it right now, but that's an expensive tool. This is a tool that just about everybody has, so I'll suffer with it. Just gotta do that to all of these. Fresh flap disc. Okay. We took a few minutes off camera to clean up these tubes. That's kind of boring to watch. So yeah, they're all nice and clean. I labeled the inside so I wouldn't forget it. So I got runner 4 and runner 3. Since runner 2 and runner 1 have to be clocked and placed into a very certain point, I'm thinking we're going to take advantage of this extremely tight fit up and very precise deal here. If I get runners 3 and 4 into here, that'll set the place for where everything needs to be. Then I can tack 2 of them up, and then we can build runners 2 and runners 1 and 2 after that with all of it together. But since this is all in 3D space and I'm limiting my tool use, you know, no clamps, no whatever. So we're just gonna try to put these together according to the actual drawing itself. And since everything was normal to that face, that means if it's flat against here, then it will be in the correct space. But if it's off a little bit, then it will not be in the correct space. So if I get these 2 locked in, get a tack on there on each one of them, then I know that we're set. So let's see if I can get this drawing here. iPads do not work with TIG gloves. This is why we should hate Apple. 4 goes to the outside, 3 goes below. Yeah. So bottom, top. Oh man, that is so nice how that fits. Dude, we're already off to a good start. So if I can hold this nice and tight, I think I'll just start with that. Can you do me a favor? Oh, I almost forgot. A huge thank you goes to Aaron, AKA Man Candy from the Garage Fab YouTube channel. I literally only had 1 day to make all of this happen, to make this build work, and I didn't want to take a chance of missing or losing any footage or any shots or anything that would have come out on this one. So I needed somebody experienced with fabrication and camera work, and he was available and volunteered his time to come out here and help me with this. So massive thanks to him. Drop a sub to his channel. Okay, so I had to rethink this just a little bit here. I'm gonna get some help. And he's not a tool, so that doesn't count and go onto this list. I'm thinking if you wanna hold this one, you know what, actually, Just keep an eye up here because you got better sight of it. So we want to try to keep these two like perfectly together because they're almost the exact same. Yeah, see if you can just weasel that on there. Get it on like super tight. Okay, I'm gonna take the collector off. And we're just gonna tic-tac those two right there. You can let go. Off to a great start. Runner 2 goes through here, and around there, and up to there. Something kind of like that. Okay, I had to bend my rules just a little bit. I'm gonna go with that block down there is a piece of scrap metal. So runner number 2, let's see if I can get this loosely placed in here, kind of lined up. As soon as I'm pretty certain that I've got it pretty close, I'm gonna mark this tube here. There we go. So I'll tack that together. I think 2 ought to do it just for the mock-up. See, this one went through there, into there. And look at that, still not touching. I friggin' love it. That looks sick. That's business right there. Okay, one more to go. Okay, this is the tricky one. This one slides in between runners 1 and 3, or 3 and 4, that's what I meant. It should slide right up to about there. Get my block back under here. Okay, so I admit I had to cheat a little bit. I had to get more tools. I did go ahead and kind of trim this to realign it. Everything is ridiculously tight here, so we're talking like some serious precision that is going to be, I mean, if it's not just right, it's going to knock your part out of whack. So I had to take quite a bit of time there to really figure out where I wanted to go with this and trim out and everything else. So. The cool thing about all this is even though I've used more than 3 tools like I originally only wanted to use, we're still using small tools that theoretically everybody would and should have, so I don't feel so bad about bending the rules only slightly. So we did already prep the inside of these, and even though this is technically like a showpiece, I'm still gonna purge it. Gotta do right on it, you know? Now, as I weld this up, I know that some of you are going to mention that I'm using a welding machine that costs about $9,000 as equipped and not the prime weld that's sitting next to me. Well, remember earlier in the video where I mentioned how lazy I am? It's just a lot faster to turn on the machine that's already hooked up than to hook up a whole other machine that does the exact same job. I mean, you could do this with like a $200 Amazon welder if you wanted. I just wanted to get that off my chest because I'm pretty sure I'll be seeing it in the comments later. Doesn't seem to distort too bad. It looks almost like it's touching, maybe slightly, but I probably have a little bit of room to tweak that. Let's see if I can get old number 2 out. Some stupid dummy tacked this to the flange. And speaking of comments, in the event that you skipped over what I was saying earlier, there is, for the month of October, a discount for you guys on Xometry's website for tube bending. It's really awesome, and if you show them some love, they might just be giving more specials in the future, so you should always check back on this video to see if there's anything more that you can use. And if you've made it this far, thank you. You might want to consider subscribing if you haven't already, especially if you like seeing this. Okay, I think it's safe to say that I could put some tacks in and we are set. I had some messed up audio at this point, but what I'm doing is sticking this argon purge line in between the tubes and pointing it at the back of the merge center plate with roughly 5 CFH or so pumping out. This is going to keep the backside of it from sugaring up and overheating that little merge plate, which is thin and super tiny. It's only like 16 gauge stainless. Yeah, I kind of was wondering where all that smoke was coming from. So much for a purge. It melted the line shut. It's probably why it came out a little bit dark. Some of it purged. Okay, this is probably going to take a little bit of a love tap to get on there, but that's all right. I can knock it around a little bit. There we go. Yeah, that's business right there. I'm a little nervous about this part. I have never welded 3D printed stainless steels. Here goes. I mean, it almost feels a little muddy, but it's all right. So about that printed material there. Yeah, I struggled a little bit. It's the first time in my entire career of 22 years that I have ever attempted to weld 3D printed stainless. It kind of welds like it's hard to explain. It's like a mix of cast iron. Like you kind of get these little sparks and stuff flying off. That probably had to do with my lack of prep. Not something that I'm totally used to with something like this. And it welds pretty funny, so. But it could very well just be me. Okay, home stretch. We got the tape there for the purge. I know somebody's gonna look in there that's a welder and be like, oh, I wonder if that was back purged. They're gonna be like, oh, it was back purged. It'll be exciting. It also feels kind of like it wants to undercut, like an oxygen sensor machined out of 303 stainless, but not nearly as bad. Like if you've ever welded one, you understand what I'm saying, but it's not nearly that bad. Oh, and it almost seems to hold heat like copper. It's kind of weird. Again, really hard to describe, but it also has kind of like a muddy feel to it, which did have me constantly changing my amps and my speed, trying to get control of it. And I also kept on switching back and forth with different filler diameters because my control of it was really all over the place. It's hard to get like a good read on it. It wasn't cooperating with me the way I thought it would, I guess. And to be honest with you, I went into this job cold. I didn't practice beforehand. I didn't, set up some coupons or anything else like that, or, even order myself a little piece of printed stainless to run some beads on. I went to it straight cold. I'm sure that didn't help, right? You should always practice before you do a job. And I think next time I'll probably hit it with a wire wheel for better prep and, again, more practice before starting the weld. But hey, it is what it is. I hide nothing. Now, all in all, I'm really satisfied. Unfortunately, we did have an audio issue when I was tapping on these ports, and I was hoping that I could demonstrate, you know, and save it to the end like as a surprise that they're actually all the same length and they make the exact same sound when you tap on them. And that was really cool. I mean, they're not the same pulse length, but yeah, they're actually the same length. So when you bang on them like Blue Man Group, they do make pretty much the exact same tone. I mean, maybe within like a couple of hertz. But it would have been really cool if the mics weren't having issues and you guys can hear that. But oh well. Look at that. Looks just like it. Online services like this are plentiful. They're becoming more and more, you know, as every day goes on. It's absolutely insane that you can just bleep and bloop your way into building stuff. And that's a great starting point for a lot of people. Like, let's just say you're in your home shop or your home garage and you're like, oh, you know what? I wish I had a tube bender. Well, you can get a tube bender later, but right now you can utilize these services that are out there and, you know, make some money. Build up a savings on it, and then, you know, you can go out and buy all the fancy machinery and stuff like that. Just, again, you don't need all of that in order to make really awesome things happen. Now, I know a lot of people have expressed a lot of interest in wanting to get into the business and things like that, and this is just another one of those useful tools in your toolbox that will help get you going. And I love it when people tell me that they've had great success and they share their stories with me, and man, I wish them all the best. I really do. It's, you know, I'm just rambling on. I've got to hurry up and get this boxed up and on its way to Chicago. Special thank you to Xometry for sponsoring this build and helping me show you guys other methods to get into this biz. Oh, I must specify because I have to shoot everything again tomorrow. No touchy. Look at that. Nowhere. Zero contact. That is just sick. All right, time to go home.